Lovely to meet all of you virtually. My name is Miriam. I'm the co-founder and CEO of DoubleWord. We're an inference platform specifically focused on high volume inference, so anything that produces a lot of tokens. And the use case that we've been really interested in over the last kind of 6 to 12 months has been long-running background agents. And that's what I'm going to talk to you about today. And I can share the slides as well afterwards. So this is by far my favorite graph in all of AI, and it's the reason why I think it's reasonable that we will achieve some kind of AGI within the next 2 years. But this graph is really useful to help understanding the trends that we're seeing in application development with AI. So the way to understand this graph is an understanding of the capabilities of AI models over time. Now, when you hear of capabilities, often people think about benchmarks and performance on benchmarks, like a model can get like 82 on a benchmark or 83 on a benchmark. But this understands capabilities relative to the tasks that they can perform, the human type tasks that they can perform. And we measure the tasks, the difficulty of a task that it can perform based on how long it would take a human to perform that task. So you might have a task that would take a couple seconds, being answering a simple question. GPT-3 was pretty good at that, answering simple questions. Then you could kind of get much harder tasks like finding a fact on a web, would maybe take us, 5 minutes or 10 minutes to browse the web to find a fact. And then you get really, really hard tasks like, training image models or something like that. And over time, the models that are released the frontier models that are released tend to be able to perform harder and harder tasks as measured by how long they take a human to perform. Now, the thing that's really interesting about this is the rate of change that we're seeing. So over this period of time between, 2019 to 2025-ish, the length of task that a new model could perform doubled roughly every 7 months. So an exponential growth. Now, what's exciting is what we're seeing over the last year and a half is actually it's doubling every 4 months. So if a frontier model now can do a task that would take a human 10 hours, in only 4 months' time, it can do a task that would take a human 20 hours, which is a really impressive rate of growth. We can see this, for example, with Cursor. This is something that they did in January where they had a model run uninterrupted for an entire week that was able to build the basic browser, which is incredibly impressive. So this kind of takes me to a theory that we have about the evolution of AI systems. We can go from early type generative AI systems, which are chatbots. You would ask a question and you would get a response back. It would be single turn interaction where as soon as you ask the question, it's already immediately answering. It's not doing anything kind of particularly special in the background. Then we got models that were able to, use tools, for example, could do web searches. And then we were going from producing maybe hundreds of tokens per interaction to now using thousands of tokens per interaction. Then we got deep research type agents that would go off for maybe 10 minutes at a time to get responses back and would use tens of thousands of tokens. And now we have, as models are getting better and better and better, models that we trust to run for long periods of time as background agents. They're persistent, they're autonomous, they're async, and they produce millions and millions of tokens per interaction, which is really phenomenal. This is a trend that Jensen Huang spoke about in the recent GTC conference in San Jose. He talked about how we went from ChatGPT to reasoning models to now kind of Claude Code background agent models. And he claims that there's 10,000 times inference demand is higher for the Claude Code and background agents than for ChatGPT, which is pretty phenomenal. We also see this kind of with the explosion of popularity in open claws as well. Open claws use a huge number of tokens and end up being very, very expensive to run as well. And I can walk through the problem that we see with this happening, which is a token problem. So if we have early type AI systems that are maybe one step. So I have a one-step system. So I put in 1,000 tokens, I get out maybe 1,000 tokens as well, and maybe I'm using the Claude Sonnet or the Quen model. My total cost to run that system is maybe a penny, maybe less, for that entire system. It's really not very expensive. But as models and AI systems get better and better and better, they can run for longer and longer periods of time. And now maybe I get a 10-step system. So I send a request, it maybe does 10 reasoning loops or 10 kind of tool calls in order to get an answer. My price then goes up from maybe 2 cents to maybe 30 cents to run that. And if I now have a model that's even smarter, if you assume kind of naive accumulation of tokens between turns, I could have entire requests that are costing like $10 or more. Obviously, I could use a Quen model and reduce that price, but it's still pretty expensive. So the first takeaway that I want to leave you with is that async agents and background agents produce orders of magnitude more tokens than previous generations of AI systems. And this sets up what I call the token problem. So this is the problem that stops people being able to scale efficiently. The token problem is that the number of tokens, you can break it down into the number of tokens produced multiplied by the cost of the tokens is the problem that you get with AI systems that run for longer and longer periods of time autonomously. So I have 5 fixes for the token problem in the kind of full length version of this talk, but I'm only going to talk about some of them in this case, but I'll talk through all of them very briefly. So in order to reduce the number of tokens that are consumed, there's a few techniques that we can do. We can do things like checkpointing and state recovery, token budget management and context management, and using caching and things like that. But in order to reduce the cost of the tokens, which is what the focus of this talk is going to be, we can do things like async inference and smart model routing. So as I said, there's a fuller version of this talk, but it'd be way too long, where I talk about reducing how you can also reduce the number of tokens you consume in async agents, but I'll actually just focus on how can we reduce the cost of the tokens that we use without impacting model quality in our async and background agents. So before I get into that, I will very quickly talk about inference, and inference is a game of trade-offs. So inference is a game of trade-offs between 3 things. You can only have 2 of them, really. You can either have inference that is low latency, i.e. you get really, really fast responses, or you can get inference that's very high quality, where you have really high quality tokens, or you can have inference that is low cost and cheap. And you can only have 2 out of the 3, and you need to pick the best one for your use case. So for example, I could have a system which is low latency and high quality. And this is good for some use cases. So this is really good for like chatbots, real-time coding assistants, and stuff like that. Or I could have a system that is low latency and low cost. This might be really good for routing models or classification models or systems like that. Or, and this is the trade-off we're most interested in, and we'll talk about in this talk, is how do you reduce the cost of your token without impacting the quality of those tokens? You end up with this trade-off, which is really good for long-running background tasks like async agents, data labeling, data processing, data generation, and batch tasks. So us as a company, we focus mainly on very, very low cost, very high quality tokens. But this trade-off isn't really available to you in the industry at the moment. So the industry currently provides you 2 options with AI APIs. You can either have real-time APIs, which are, your standard way of interacting with AI models, which are more like low latency and high quality tokens. Or you can have batched APIs, which are cheaper. They're 50% off. But the ergonomics mean you really can't build async agents and async agents and background agents with them. So your real-time API has the ergonomics to build background agents with. It's probably what, if you're building a background agent, what you're using. But it's really, really expensive, and it doesn't do anything to help us reduce the average cost of the token that we were talking about earlier. Or you can use batched APIs, which are about 50% off, but they don't really have the UX that you need in order to be able to build background agents and async agents. So we as inference providers have been thinking about what do background agents actually need. So real-time APIs are too expensive. Batched inference APIs just don't have the ergonomics. And so what do async agents and background agents actually need in order to be able to scale? Well, they need ultra low cost tokens. So as I talked about earlier, we can see this exponential growth in how AI systems are getting better and better. They're using more and more tokens. So I need tokens that are really, really cheap in order for me able to afford that scaling. I need tokens that aren't slow. So unlike batched inference, I can't wait 24 hours for my response if I'm having my model do 30 tool calls, for example. And so I need the interactivity of my API to be decently good. I need full tool calling support. I need elastic scale, which is very important. And I need to be able to, for example, stream results. We call this a new category of inference, which is called async inference. You can think of it as an analogy to like async agents. And therefore, there are actually three kinds of inference that exist. There's real-time inference, which is good for chatbots and real-time coding assistants. This is your trade-off that is expensive but low latency and high quality. You have your async inference, which is really good for background agents and any kind of long-running task that has a lot of steps. And I have my traditional batched inference as well, which is really good for embeddings, classifications, extraction, content generation, that kind of thing. At DoubleWord, we focus on the trade-off of cheap, high-quality tokens, and we offer a high-throughput inference API for our async inference and a batched API as well. The nice thing about our async inference API is it's the same cost as a normal batched API, but you get the interactivity so you can actually build applications with it. And our batched is even cheaper than normal batched APIs. You can kind of see what this will end up looking like. So for example, our async inference API is the same price as like Fireworks' batched API, for example. And all of these are much, much cheaper than like an Anthropic API. And so if we're considering the cost to run background agents, this is the price for 1 billion tokens. You can see the difference is $10,000 to $250,000. So something suddenly goes from being non-economical to economical. So, second takeaway is that not all inference APIs are built the same and they all have different trade-offs. So, one of the fixes that we can implement is called smart model routing. So, I've already talked about the existence of APIs other than your real-time API. You can obviously have these APIs that are much, much cheaper, like your async inference endpoints or your batched inference endpoints. What we can do when we get a request in a long-running agent is not every request needs to go to the real-time endpoint because the real-time endpoint is really, really expensive. And instead, we can route some of the requests to batched or async inference endpoints. So what that might look like is my red ones are my real time. I might route any real time requests like that I'm directly speaking to the user with my real time inference, but actually the majority of use cases could be going to background inference or async inference APIs. And remember, as I said earlier, these blue ones are like 50 to 90% cheaper than the red ones. And so overall, I end up with a much, much cheaper token cost than I would have had before. Here's an example of like the kind of routing instructions that I'm talking about. This is the kind of thing that you could have in your OpenClaw. So you could say something like in your OpenClaw, if it's a real-time task, then I want to send it to a real-time API. Maybe I'm sending it to OpenRouter or something like that. But if it's a non-real-time path, maybe I'm sending it to an async inference API or a batched API instead. So going back to the 5 fixes the token problem, the two that I've been focusing on, the async inference and the smart model routing, are really, really, really valuable to be getting the net value, the net cost of your tokens to be much, much cheaper. Async inference does this by trading off some of the interactivity of your super real-time endpoints in exchange for batch pricing. So you get batch pricing in order to build your async agents. And your smart model routing is a way to ensure that your background agent only sends requests that need to go to the expensive real-time API or the really big model that actually go there. So going back to this graph that we talked about at the beginning, we should expect that the trend is going to continue, that as models get better and better and better, they will be able to perform more and more complex tasks, which will have them running for longer and longer periods of time by themselves. And that means as we build our AI systems, we need to take this into account and being smart when we think about what inference provider to use. So some takeaways. Agents consume orders of magnitude more tokens than any traditional AI app. You can reduce your token count through a couple of methods like checkpointing, budget management, context compression, and hierarchical architectures. And you can reduce your token cost through things like async inference, smart model routing, and also microbatching as well, which I didn't talk about that much today. Async inference is a new category, and it's purpose-built for background agents. And we are DoubleWord as the first provider of these async inference endpoints. Now, I know I've talked a bunch about async inference. You probably want to try it. Anyone who signs up with this QR code will actually get free tokens if they want to start playing with async inference. And so if you have like an OpenClaw or any kind of agentic type use cases that you're interested in, you can scan this QR code and it will give you free tokens. So you can actually try out what we've been talking about in today's mini talk. But I've tried to save some time for questions. So if there's any questions, now's a good time to do that.